Okay, so I'm going to recap real quick. We are going to use quadratic and linear regression to take a data set, find a curve of best fit, and then we're going to use that curve of best fit to make some predictions. We drew a data set that looks mostly linear and one that looks mostly quadratic. We talked about R squared, and this is a measure that's going to tell you whether or not your data fits the equation well. If it fits it well, it will be close to 1, and if it doesn't fit it well, it'll be close to 0. And its name is the coefficient of determination. I never call it that, I just call it R squared. Okay, so next thing we're going to do is we're going to enter this table into Desmos. So your table will be vertical instead of horizontal in Desmos. And let's read what it's about. It's about the fuel economy in cars. So if you look at the fuel economies here, right, when you're going slow, you've got a low fuel economy. And as you speed up, it gets higher. But then as you get really fast, it gets lower again. So noticing that trend, would you say that you think this is going to end up being linear or quadratic? Probably quadratic, right? Because it has that turn where it goes, it's going up and then it's going down. But here's how we're going to graph it in Desmos. So I'm going to pull my Desmos up. You're going to go over to the plus here and add a table. And then you need to type it in. We're going to put speed in the X. Okay, and then you're going to put fuel economy in the Y. All right. Once you have that in, you probably can't see any of the points, and you might have tried to zoom out to see them, but sometimes, in this case, the zoom out might be okay. Sometimes the zoom out is not the best way to see your points. The very best way to see your points is to go down to the bottom left of your table and find this little magnifying glass that says zoom fit, and you want to hit that magnifying glass. Okay, and it makes a really nice window for your data points. And looking at that, I see you were right. This is absolutely quadratic. All right, so now we need to know which function we're going to use. I'm going to switch back real quick to my document camera. Since it's quadratic, we're going to use this one. Okay, it looks a lot like the standard form of a quadratic equation, but notice it has these little 1 subscripts, and instead of an equals, it uses a tilde. All of that is important to Desmos. This is the code Desmos uses to say, okay, take the points from my table and then put them in this equation. So on the line, I'm just going to rewrite that. Y1 tilde ax1 squared plus bx1 plus c. And all I did was copy it from right here. I didn't make that up. Something that's interesting is this is called the standard form of the equation. We have also seen equations in vertex form and also in vectored form. You can use any of the forms to find an equation, but we're going to be using standard form today. All right, so now I'm going to go back and type that in Desmos. So below your table, go to the next line. You're going to type Y. To get the 1 to go low, you don't have to do anything special, just press the 1. The tilde is next to your number 1 key. Do shift in that key to get your tilde. AX1, and then you can get your squared from the keypad. And then plus BX1 and plus C. Look at that beautiful parabola it gives you. So nice. All right, let's look at our R squared. Is our R squared close to 0 or close to 1? Yeah, it's really close to 1. All right, check on your neighbors, see if they have it. See if they need any help. Okay, so we're going to be writing an equation that has this A value, this B value, and this C value. We're going to round to 3 decimal places. So the first one will be negative 0.01, and then the other one rounds up to 2. So I'm going to write on my paper while I'm looking at this, and then I'll show you my paper. I'm going to write for my equation, y equals, not tilde this time, negative 0.012x squared, and I will show you this, I'm just writing it while I look, plus, hi Dion, here you go, thank you, plus 0.992x plus 10.153. Rounding it to 3 decimal places. And then I'm going to write down the r squared while I'm looking at this. 0.995. So let me show you that now. All right. So now it says to use the equation to predict the average fuel economy of a car traveling 65 miles per hour. So we have to look back. Is 65 miles per hour an x value or a y value? Yeah, it's x because it's a speed. So we're going to substitute 65 for the x in your equation, and you're going to use Desmos to calculate that. When you do use Desmos, don't put y equals in the Desmos. Just start with a negative 0.012 and then parentheses 65 squared. Right here, isn't the question. And then plus. So the equation is useful in all kinds of situations, and then we're asked to use it to find out the fuel economy if you're going 65 miles per hour. All right, so I'm gonna start putting that in my Desmos. I want you guys to do the same. All right, so yes, I'm getting the same as you. I'm getting 23.933 is my fuel economy in miles per gallon. Anybody have a really fuel efficient car? Maybe a Prius or an electric car or something? Nobody has that? I always wish I had one when I have to go get gas these days. All right, any questions before we look at the back? You guys can't see my screen. Hold on. There we go. Any questions before we look at the back? Okay. Let's turn the paper. Now, if you came in late, please, please, please have your Desmos open because I want you to be able to try this. So now we have a shoe company that develops shoes for marathon runners. And it's been improving its shoe technology each year. So the table shows the number of kilometers that a pair of shoes is able to handle. So years after 1990 is your A value. So 6 would be what year? 1996. Good. 19 would be what year? Close. 2009. Yeah, 2009, right? Would be 19 years after 1990. And these are the kilometers a shoe can handle. Did you know that there's like a limit on shoes? Sometimes they can't, they're just worn out, right? Especially if you like run a lot of distance, your shoes are eventually going to run out. So anyway, we're going to graph this data, and then we're going to decide if this data looks more linear or quadratic. All right. So go back into your Desmos. If you want to, you can delete your last table and make a new table. Or you could just open a new screen. So if you want, you can delete everything. I'm actually going to leave that there for my next class. And you need a table. And you're going to put these in for X and please, please, please do this on your own screen. All right, so I'm going to press the Zoom Fit button here, and what do you guys think? Does this look linear or quadratic? Linear. I agree, because it has no turning point. It just keeps going up. It's not perfectly linear, but it's much closer to linear than quadratic. So that means we need to use the linear function from the front of your paper. Let me switch back here. Okay. So we said linear, and we're going to use this function y1 tilde. I think it says ax1, right? Yeah. Plus b. Anybody have an idea why it says ax instead of mx? Okay. Let's take a look back here. So it is linear, and that's why we're using this one instead of this one. But I was thinking most people were used to seeing it say y equals mx plus b instead of y equals ax plus b. You can call this constant here a or m or any letter you want. It doesn't matter. But the reason they're using a is for consistency. You see how a is the coefficient of the first term, and then b is the coefficient of the next term. So they're doing consistency there. But if you really like m, you can use m instead of a. You don't have to do a. Okay? All right, so I'm going to put that back in my Desmos. If you haven't done it yet, now's the time. Below your table, type it in. Okay, so I have an a value here and a b value here, and we're going to write those to 3 decimal places. So y equals, and instead of a, 0.858, x plus 72.643. I'm getting those numbers from down here. My r squared is 0.961. Is that closer to 0 or closer to 1? Closer to 1, right? So it was not as good of an r squared as before, but it's still pretty good. All right, let's see how that looks on my paper.
Where does the 1 go?
Which one?
The little one?
Oh, this little one here?
Yeah.
Okay. So actually, I want to go through a couple things real quick. First of all, the reason why we put x1 and y1 into Desmos is because when you look at the tables that you create, it's there at the top. So take a look here. We have x1 and y1 at the top of our table. And so that's why we use it in Desmos, because it tells Desmos where to find the numbers for x and y. Now, some of you are having trouble. It's not working, right? Here's why. Look at the top of your table. If it's the second table that you made in Desmos, it might say x2 and y2. Does anybody have x2 and y2 at the top of your table? Okay. So if that happened, it's okay. Listen, if that happened, it's good, because now you know what to do, which is this. If your table has x2 and y2, then down here in your equation, you also want to use x2 and y2, okay? So type your equation down here using x2 and y2 instead of x1 and y1 if that's what's at the top of your table. All right, secondly, once we have our values for a and for b, we're not going to have to write the special way that Desmos needs, because we're writing an equation for ourselves, not for Desmos. So then we want to go back to writing it the normal way that we're used to. Y equals ax plus b. So use an equal sign and you don't put the ones after it. Okay? All right, we're going to answer C. Go ahead, Josiah. Is that not what you got? for the r squared. So it's in the, look in your Desmos. And it's right here. R squared 0.961. No. It just gave it to me. All right. For C, use the equation to predict the number of pairs of shoes the company expects to sell in the year 2015. I'm going to solve C down here because I don't really have room. 2015 is how many years after 1990? 25 years. So 2015 is 25 years after 1990. How could I figure that out if I didn't know? How did you get 25? Subtract it, right? So you would do 2015 minus 1990 and it would give you 25. So then we're going to put 25 in for our x. So you're going to do 0.858 times 25 plus 72.643. And then go ahead and find that answer. All right, so here's what I'm getting, 94.093, and then Blaine told us that the unit is what? Kilometers. Very good. Kilometers. All right, let's do D. Say it again. The number of pairs of shoes they expect to sell. Oh, they just answered. We answered the wrong question, right? They asked the wrong question. Do you guys see that? So Steph points out that we expected them to ask a different question and we ignored the fact that they actually didn't. So let's change the question. We can't predict the number of pairs of shoes, right? We can predict the distance, right? Let's just predict the distance in 2015. All right, then going to D, how reliable is your prediction? What are we looking at to find out how reliable is your prediction? Okay, so don't make it a percentage, right? But that is the right number to look at. What number did you look at, Robert? The r squared. So look at the r squared, guys. Remember that r squared value? We wrote it on our paper. Oops, it's here too. But it's right here. Is that close to 1? Yeah. So very reliable because r squared is close to 1.